this particular video, I will explain the problem wave array. Today's problem is really interesting and asked by companies like Microsoft, Google and Paytm. And guys, today's problem is really easy as well, so I'll not take more than 5 minutes to explain everything you need to know about this particular problem. Starting right away from the problem statement, so it says that given a sorted array ARR of distinct integers, your task is to sort the array into a wave-like array in place. What is in place, guys? When it says in place, so this means that the space complexity is going to be O of 1. We don't have to use any extra space while solving the problem. After this, talking about the wave-like array, so this is a wave-like array. You can see that the first element is array of 1, which is larger than array of 2. So let me show you guys. See, let's say this is array of 1. So array of 1 is larger, right? So array of 2 will be somewhere below this array of 1, right? After this we have uh, array of 3. So array of 3 is greater, array of 3 will be here. Then we have array of 4, which is smaller, so array of 4 can be somewhere at this point. Then we have array of 5, which is greater, right? So array of 5 can be here as well. Like this, we are following a wave like structure. You can see that this is following a wave like structure, right? Always make sure that first value is larger, then smaller, then again larger, smaller and larger, and so on, right? So this is the series that we are following. Now, if there are multiple solutions, you have to find lexicographically smallest one, and one note is also given. It says that given the given array is sorted in ascending order, and you don't need to return anything to make changes in the original array itself. It basically means that you don't need to return anything externally. You have to make changes in the original array itself, right? Now, guys, you may ask one question from me that you are only considering smaller and larger values. You are not considering this equal case, right? If I am here, so value can be equal as well, then equal, then it is not a wave-like structure, right? So guys, let me tell you one thing. The question says that we are given distinct integers, right? So this condition doesn't make any sense here, so I can remove this condition because we are not going to have equal elements in any case because we have distinct integers only, right? Now an example is given. For this example, guys, n is equal to 5 and we have 1, 2, 3, 4, 5. So see, there are multiple wave like array for this particular array. The first one is can be 4, then 3, then 5, then I have 1 and 2. So you can see that larger, smaller, then larger, then smaller, then again larger, right? Now guys, see, second wave like array can be 3, then 1, then 2, then 4, then 5. After this, I can have 2, 1, then 4, 3, then 5. And even this is the lexicographically smallest wave-like array you can see here. See, why I am saying this is lexicographically smallest array? Because you can see that this is my small value, this is my large value. So large value is here, small value is here. Now for this, large value is here, small value is here, and this is going to remain same, right? So guys, this is going to be the output, which is 2, 1, 4, 3 and 5. So we can simply return this particular output here. Now I hope you have understood everything related to this particular problem. So guys, let me explain the solution. I have written the main idea behind the wave like array here, and one example is also written here, right? So guys, you can see that for this particular array, if I check any pair, any distinct pair, or any non-isolating pair or non-intersecting pair, you can see that I'm not going to consider this pair, right? Why? Because this pair and this pair is going to intersect. So let me remove this. I'm only considering those pair which are not intersecting. So this is my first pair, then I have this particular pair. So if I consider every pair, then you can see that the first value is going to be larger value and second is smaller, then again larger, then again smaller, right? So what I will do is, the approach is quite simple. I can start moving from the left and then I will swap first two values, then I will come here, then I will swap these two values, then I'll swap these two values. This way I'll get my answer as 2, 1, 4, 3 and 6 and 5. Interestingly, this is going to give me lexicographically smallest wave like array, right? Why? Because I'm moving from the left and I have the sorted order from smallest element to the largest element. So guys, this is very obvious that I'm going to get the lexicographically smallest string, right? So my bad, lexicographically smallest wave like array. Now all I need to do is I need to write the pseudocode. So pseudocode is quite simple. I equals to 0, then I smaller than n minus 1, then I plus equals to 2. Guys, there are two things which are important to understand why this condition and why I'm adding 2. See, I'm adding 2 is quite simple to understand because I will first start with this particular pair, then I will simply directly jump to this particular pair, right? And then I'll jump to the next pair. So I'm considering two elements at a time. So in this particular loop, I'm going to consider array of I and array of I plus 1. And guys, see, let's say I have a odd size array 1, 2, 3. So I'll first start with this, then I'll come to this. But for this array, there is no any element which can be paired with this particular element, right? So that's why I'm not considering this element. So that's why I'm running loop only till n minus 1. Now, one more thing important to understand is I'm going to swap these two values, right? So I'll simply write here swap, or I can tell you how we swap the values. Temp equals to array of I, then array of I equals to array of I plus 1, then array of I plus 1 equals to temp, right? So guys, this is the whole idea behind the solution. The space complexity is O of 1 as the problem asks us to do, and the time complexity is going to be O of n, right? So this is all about this video, guys. Let me quickly show you the code now. So this is the code, guys. This is the code in Python. In Python, this is just a two-line solution because all we are doing is we are swapping in just one line. After this, we have this particular solution in Java, and this is the solution in C++. Now, I hope you have understood everything, guys. So this is all about this video. Thank you.